Right. The new build, I just wanted to give you an update. I haven't got any coils connected to it yet. I've just finished putting the drums in. I might actually take the drums out again because the spaces I put in there were a little bit too wide. So I'm printing some new spaces. But the way I've designed it, I've got a center bearing in there now. Right in the middle, the midsection there, there's a round disc with a bearing in the middle. So there's actually three bearings. There's one at this end, there's one in the middle, and there's one at that end. The reason for the three bearings is because I can't get the word out. Is for stability, because when you get to higher revolutions per minute, the drive shafts, the actual 6mm shaft, can actually start to resonate a bit and start to oscillate, and you get a lot of vibration. So the previous build, I learned a few things about the previous build, which was the short two-stage one, which was you saw in previous videos. So I decided, well, I don't want to take any chances because I had some issues with stability even on the short drive shaft, which was literally this shaft here, which is very short. As you can see, it's very short compared to the one that's in there. So I decided, well, I'm going to go with a three bearing system, and it's more stable, it'll be much more resilient, more solid. So what I'm doing at the moment is I'm doing a static test with a motor. I'm just going to spin the whole thing up to test at RPM speeds, at high RPM speeds, just to check for vibration and resonance. So it's not a hands-free situation. I mean, I can't do this with, I've got to stick the phone on something. So what I'm going to do is I've just got the battery there. I've just got my old motor, which I used to use to run this thing before I went to direct drive system. So all I'm going to be doing really is to get this thing up to speed, and my RPM meter's over there, and I've got the RPM sensor hooked up down there onto the wheel, and I'm going to spin this up and see how much vibration there is, and check to make sure I've got everything balanced right. And ideally it needs a few more days of curing for the acetone to dry out. Now let me just get this going on here. My space is a little bit too thick. I need something a bit thinner. Let's see, what can I use to prop this on? Right, that's a little bit low. Actually, I'll use one of them spacers I printed that they were that were a bit too thick. That should be just right for this, ironically, probably. Let's see. Yeah, well, right, okay, so I'm going to spin this up with the belt, and once I've got it running, I'm going to grab the phone and show you the RPM, and we can listen to the amount of vibration. You'll have to ignore the printer in the background because that's going as well. So I've got to hold this motor, and then I'm going to knock the belt off because we don't want noise from the motor interfering with the test. So if I can get this, if I can reach the wire to clip this lead on. Right, so this is going to be interesting. Right, are we ready? I can see we're at 3000 RPM, 5000, 6000, 7000, 7500, 7600. Oops, came off. The belt came off. Listen to that. That's as sweet as a nut. It's slowly dropping. That's as sweet as a nut. Still going. That's freewheeling right now. It's the mass. Slowing down. So there's no coils in there. There is a coil in there, but it's not connected. One coil in. That is sweet as a nut. I can't believe it. There's no vibration. The table. I'm going to put the phone on the table. No vibration. That I've got it balanced perfect. I'm going to do that again because my belt came off before. Let's get this spinning again. Oh, it's still going after it stopped. We can't put the belt on. Still going. We're at 2000 RPM and it's still going round. Wow. Right, let me just put the phone back on here a minute. Oops, the phone nearly fell over. Right, let's get this belt on. I'll probably need two of these spaces. That is perfect, the balance is really good. Right, let's get this motor hooked up. I'll just stop it because it's still going around. I need to get this belt on, you see. I can't put the belt on if it's spinning. Right. I'm going to do another test. I've got to get this motor perfectly straight, otherwise the belt comes off. This is only for testing the balance and everything. Right. Are we ready? Oh, I'll bring the RPM meter over here. That would be good. Hang on a minute. If I can get it over here. My probes were tangled up. Alright, RPM meter. Let's put that battery over here somewhere. Yeah, the better with the RPM meter right in the shot. Actually, I think I can stick the RPM meter no, it won't go in there. I'm just going to stick the RPM meter down here. Right. Oops! Oh, it's not stuck down properly. I need something heavier to hold it down. Give me a minute to work this out. I'll move this blooming mouse out of the way. I've got a lot of clutter around here. So as I say, this is only a vibration test. It's stability, that's all it is, nothing more. It's extremely stable. Right, I still want to test. I want to try to get it faster if I can. We were nearly at 8,000 RPM, and before on the previous build it used to rattle like crazy. Yeah, I need some steel ruler. That might work. Yeah. So stick this to the steel ruler, then put the leg of the, no, I'm not going to stick the leg of the device on it. Oh, it's going to hold it anyway. It's going to watch I don't shot the battery terminals out on the steel ruler. Right, so there's the RPM meter. We can see it in the shot. Bottom of the screen. Now, let's do another test, shall we? Now I won't have to panic and grab the phone, you see now, because it's all in shot now. Right, here we go. Let's do another test. Oh, come off again. Ah! Damn it. Hang on. I'll have to stop it. Wow, that's a lot of friction on there. Ah, my fingers are burning. There's 4 drums on there, so there's a lot of mass. There's probably over 1 kilogram of weight on it. That's why I went with 3 bearings, you see. Quite a lot of weight on there. Right. Let me get this lined up so it's not going to fly up on me again. It's difficult to hold this and keep it steady. Got problems with my wrists as well. Right. There we go. Let's try again. Stay on. Stay on. Oh, you twat. Come up again. Ah, flipping thing. This is what happens when you're holding it by hand. See if I can get the motor to catch up. Ah. Flipping, what's wrong with the belt? I won't turn the belt inside out. There's something. I'm having issues with this flipping belt. It worked yesterday. Why has it been awkward today? It's probably got some crap on the pulley. Alright, I've got the belt inside out. Now let's power this up again. Don't come off, baby. Oh! Flipping belt. Why does it always happen when you're filming? It only happens when you're doing it on video. Let me put this on the table. Right, that's it. If I put the motor on the table, twat. Right. It only happens on TV, as they say, or on video. I don't have a TV anyway, so right, let me try this, see if I've got this lined up. I'm going to hold the motor on the table, so it's going to be noisy at first because the motor's resting on the table. I want to keep it flat, you see. That's as fast as it's going to go. That is really good. I can't feel any vibration. It's just nice, sweet sound. Yeah, I'm happy with that. That is brilliant. That's so quiet. The camera should pick up any vibration from the table, but I can't feel any. I've got my hand on the table. I can't feel any vibration at all. I have got it on rubber feet. I made some rubber feet, but that's beside the point. The other one used to vibrate pretty bad. This one doesn't. Still going. It's freewheeling right now. That's the printer in the background that you can hear that's clicking away. Yeah. Anyway, that was the test. That was all. It was just stability, vibration, and that concludes this experiment. So at least we can go up to the next stage, which is to start fitting the drive circuit, and most of the coils are actually over there and over there. They're scattered all over the place. So I've got to fit the drive coils and the output coils and everything else. But before I do that, I've got to pop the end cap off, which is got little nuts on there now, so I can just unscrew the nuts. where my timing coils will eventually be, because I'm not going to use those straight away. I need to build a preamp for those. I'm going to use a separate set of timing coils, which I'll put on the outside for now, because these little timing coils, they only produce about 0.7 volts AC, which is not enough to trigger my circuit, my existing circuit, without a preamp. So I need to build a preamp for that. So I'm just going to use the original timing coils that I used on the other device around this, on a vacant slot on here temporarily, until I can get a circuit built for because I've still got this other circuit to build, which is on the breadboard across the room, which is right over there. So anyway, so that's that for now. Yeah, thanks for watching.